Or you have to parallelize, but we're not going to talk about that right now. But that's the big thing, making matrices. Now, where else do you have to make matrices? Think about our vorticity equations. I'm going to go ahead and erase here. There's going to be 3 matrices in this problem. And if we look at this equation here, ultimately, check it out. We know how to do this now. Because remember, this was just solving for the stream function. Once I get it, right, I could do backslash on that thing, and I get the solution out in MATLAB. But ultimately, what we're kind of advocating here is I have this operation. This is just going to be equivalent to that. Matrix A does 2 derivatives in x, 2 derivatives in y. All I got to do is take any vector, multiply that matrix. I've got what I need. Here, I'm going to have things like omega x, omega y, psi x, psi y. Here, I'm taking just the derivative in x. Here, I'm taking just the derivative in y. And this is going to be equivalent to some operation like this. Here are the 3 matrices you're going to build for this thing. You're going to have one matrix that takes 2 derivatives in x, 2 derivatives in y, constrains periodic boundary conditions. You're going to have a big matrix B that takes a derivative in x, okay, and constrains the boundary conditions. Derivative in y constrains the boundary conditions. These 3 matrices you have to get absolutely dead on correct, okay? And so I think it's going to be homework 3, and that's all I'm having you build is those 3 matrices. Because you cannot do the homework if you don't get those right, right? All this evolution of vorticity and stream function, you've got to get every single one of those 10,000 by 10,000 components dead on, or else the whole thing's off, okay?